Hello, everyone. Welcome to this Malt Academy. Before we start, could everyone tell me in the comments if you can hear and see me correctly, and also if you can see and hear Wasim correctly?
Hi, everyone.
Okay, it sounds really good to me, so we can start. Perfect. So first and foremost, my name is Julia, and I'm a community builder at Malt, but in France. This Malt Academy is uniquely in English because we wanted to open the questions and the subject internationally. So we're really happy to welcome people from England, Germany, Belgium also. So welcome everyone to this Malt Academy. I just would like to present quickly Malt to all the people that don't know who we are. We are a platform that connects freelancers to clients. Our goal is to help you as a freelancer find the perfect mission for you and to help the clients find the perfect freelancer for the mission and their needs. All you need to do is to create a profile on Malt, and then we will help you find the mission that we have and we will connect you to the right clients. My job is to create a sense of community and give you all the advice that I can on the mission and how to make your profile as optimized as possible to find the perfect mission. And it is also to ease the entire process financially because everything is direct on Malt. You can talk to the client directly on the platform. You can give a quote to the client. Everything is automatic. The quote will be sent to you automatically at the end of the month. You are also insured to be paid at the end of the mission. And everything that's administrative is also automatic on the platform, so you don't lose any time during your mission. We do everything for you. You just have to be reactive and to have a profile. That is basically it. If you have any question regarding Malt, I will take all of the question at the end of the Malt Academy. However, if you have any question during the conference for Wasim, you can write them in the question section of your screen, and we will give in 30 minutes. If Wasim, you're right with this, in 30 minutes, we will answer a couple of the first questions. We will stop the conference, and then we will start the conference again, and we'll do the rest of the question at the end. I'm done. So, Wasim, the floor is yours, and everyone, please enjoy the Malt Academy, and I will see you in 30 minutes.
Thank you. So, hi, everyone. Today, my Malt Academy is about an introduction to React 3 Fiber. I will show you what we are going to build before introducing myself. So we are going to build this table configurator. You can adjust its width, change the layout of the legs, and the colors of the legs. So we will build it together. So now, before jumping into the code, let me introduce myself quickly. So I'm a freelancer DevRel at Elestio, which is a platform to host your projects and host quickly fully managed open source services. I'm also an indie hacker, which means I'm building my own project, which is named FeedIQ. And on the side, on my free time, I'm a tech content creator on YouTube, and my channel is Wawa Sensei. It's where I do my tutorials, like the one we will do together. And I'm French, so that's why I put a baguette, but I'm living currently in Tokyo, in Japan, for a year with a working holiday visa. So what we will cover today is a bit of Three.js, but I won't cover the basic. We will use it, but I will give you some insight to really get started by yourself later. But we will see some advanced feature using React 3 Fiber that will do the job for us on top of Three.js. We will see how to load a 3D model, and we will see how to do a UI for customizing and do interaction between our model and the React 3 Fiber interface that we will use. So before jumping into the code, let me show you the Blender file. So this is something I built really quickly because I'm not a 3D designer. I just do it for tutorial purpose. So we have a table. You can see that I separated the legs. So we have this layout, and the left and the right is separated. It's because when we will adjust the table size, we can animate the legs more easily. And we have a texture here on the plate just to have a better render. Okay, so now let's jump into the code. So I prepared a template where you have some things ready to use. It's available on my GitHub account. I will put the link in the end so you can reproduce it at home. I have the starter pack, which is what you see now, and also the final result so you can use it and adjust it to create your own project. So what we have loaded in the starter pack is React 3 Fiber and Three.js. So we can see them here in the dependencies. So React 3 Fiber, which is the library that interfaces Three.js in React. And we have React 3 Dry, which is a library that offers ready-to-use components to simplify our lives. Because if you write directly Three.js code, it's maybe 10 lines to do something that in one line React 3 Dry is doing. So we have our app. It contains a canvas, which is the part where you will put your 3D things. And we have a component I created, which is named experience. So I have a lot of things commented to get started, but just let's have a look at this. We have orbit controls, which come from React 3 Dry. So it's just a helper for the camera. And we have a mesh with a basic material and a box buffer geometry. What it does is it displays a cube. So that's what we see on the screen, but it doesn't look in 3D because we have a standard material and there are no lights. So we can rotate it, but let's fine tune it. So instead of using a basic material, we will use a standard material. So if I refresh and I open it, it looks black because we don't have lights on the scene. So what we can do is adding some light. So here, let's comment it. So we add an ambient light with a half intensity. So now we can see our cube again, but it looks flat because an ambient light is diffused all around and there are no shadows from it. So let's add a spotlight. And to be able to see it, let's add another mesh, which is a plane, just in order to have some dimensions. So let's reload, and we have an error. I don't know why. Let's comment the mesh, maybe it's related. Okay. So now, why the mesh isn't working? Oh, it's because it doesn't know double side from 3. Okay, now we have the plane. We can see the spotlight, but we don't have shadows. But it looks less flat because the spotlight is coming from the right to the left, and we see a bit of 3 dimension. But let's enable shadows, and with React 3 Fiber, it's very easy. You can see on our mesh, we have cast shadow. On our light, we have cast shadow. And on our plane, we have receive shadow, but we have to enable it globally. So on our canvas, we just have to add the props shadows. So I hit reload, and I reload the scene. And now we can see a nice shadow here. And it looks more real and in 3D. So this is just getting started with React 3 Fiber. We won't use it. What we'll do is remove this and remove everything. And in reality, it comes with this, the starter pack. You have this cube with mesh normal material that doesn't require light. and we have this. So now what we will want to do is to add a background, a scene, and have some shadows. And for this, we will use React Free Fiber and a dry library. So I will put the link in the description. And what I do when I want to achieve something and to learn new things is to go into the examples section. And the one I found is named State Preset for 3D models. So it's exactly what we want to achieve. So we will just copy it and use it. So we can see they have a custom camera position that we will copy for us. So on the canvas, let's copy it. And then their model, which is this car, is wrapped into a stage. So it's a component from React 3 Drive. So let's do the same inside our experience. We will wrap our model. Well, for the moment, it's just a cube, but later we will load our 3D model. And we need to import it. We might have an error here because the color is not defined. So we will use the one from the CSS. So this is it. And it's something that you use to generate a shadow with a specific color, so it looks better. So here we have it. And then on the orbit controls, they also add some options to limit us how far we can go on the height. So now I can't go up or down. So let's copy it too. Okay, so now I save. And let's look what we have. No, not yet. So here the camera is too close, so we will adjust it. And we can see the shadow, so we'll need to look on why. So here on our mesh, we need to add cast shadow, so we'll be able to see it. Okay, we see it here. And the camera is too close. It's because adjust camera is set to 0.9. You need to check the documentation from React 3 Drive. So let's save. And now we have some space. We will fine tune later with the correct model. And I'm still locked on the upper side. So instead of having a minimum polar angle, we will set 0. So now I can go exactly on top. I can go further and I can go below. So it's perfect for what we are trying to achieve. Okay. And maybe we'll position the camera a bit on top, not be just in front of the cube. So now it looks better. And you can see the animation is coming from the stage. So we did nothing, just using ready-to-use components, and it already have a nice and smooth shadow and some animation with the camera. If you want to do it just in pure vanilla JS or with Three.js, it's way more line of code. Okay, so now let's load our 3D model. So what we will do is I put it in models. We have the GLTF file here. So we'll use npx gltf j6 and the model. So models table. What it does is that it goes through the model file and it generates a component. So the file is, where is it? Remove table.js. Okay. Perfect. So it generates a component, a React component with all the mesh I showed you earlier with Blender. So we'll just copy it, delete it because it's not where I want it to be. And let's create table.jsx. We'll just rename it table. And there's an issue in the path, so we need to do models. And it's set at 2 places because it also uses a preloader. So if you want to preload it before rendering, it's already loaded. Okay, and now instead of displaying our cube, we will display our table. Okay, so here we see we don't have shadows because we need to enable them, and we see all the legs at once, so we need to fix it. So inside our table, on every mesh, we need to say it casts shadow. So we'll do it quickly. Perfect. And now if we reload, we can see the shadow. So now we will add our user interface to be able to configure our table. So I prepared a component, so in our app, next to the canvas, because you don't want to put HTML inside the 3D canvas. Interface, by the way, doesn't want to import it. So let's type it manually. Okay. So now it's loaded, but it does nothing. We just need to connect it. So here it's the interface. And I commented it, but we have a context named configurator that we will use to update our value here and be able to act accordingly on our model here. So let's create our context. New folder, context, configurator. Okay. Okay. Use configurator. We will create a hook to be able to use it later. Okay, perfect. So here in our provider, what we will return is the context provider, and we will have some values here. So let's use the same that I prepared. So we have the width, the legs, and the legs color. Let's start with the legs. So legs. And we will make them available everywhere in the app. So legs and set legs. And inside our application, well, before we will put it here, we will use our context. So we wrap our app inside the provider. Okay, so now inside our interface, we will plug it back. So we only have legs and set legs from our configurator. So it's a UI I built using Material UI, so we don't spend time building it. So we prepared the legs layout. So what it does is when we change the value in the radio button, it will call set legs with a new value. So now if we reload, we have an error. Why is it? I don't even have the error displayed, which is weird. Okay. I don't know why it's not displaying anything. Oh, I know. It's my hook. I forgot to wrap the children here. Okay, so now I can switch it, but nothing is happening because we need to go into our model and act accordingly. So in our table, we now have access to legs from our hook. And I will do something very ugly because we need to be quick. So if the legs are equal to 0, we will render those legs, which are the left and right leg for the first layout, and we will do the same for the others. So here, and here. It's the second and first layout. Okay, I made a mistake somewhere. So here, it's closed. Perfect. What have I done? Okay. Here it's open and closed. Okay. And here it's the same. I will cancel to see what I have done wrong. Okay, let's do it. I don't understand what I'm doing wrong, actually. Let's just load it. Okay. So now I should be able to have one leg disappearing, but I need the other one to disappear. So here it's legs equal 1, and we display this layout. Okay. And here the last layout. Okay, now we should be able to switch the legs. So it was quite easy, but you can see on the shadow, it's not refreshed because only the table model is refreshed, but not the stage. So one quick fix we can do is to go to our experience and just to say we are using the legs. So this way we are sure it will re-render the stage and it will re-render the shadow here. So it's a quick fix, not the cleanest one, but at least we should see that it rebaked the shadow here. And now it looks way better. So now let's change the legs color. So let's go back to our interface. Here we will enable the legs color change. I will copy the color to set it to default when we will create it. And how is it named? Legs color and set legs color. Now inside our hook, we will create them. So legs color, set legs color equal use state. And I will set the default value to the black color. And I make them available. Okay, and now inside our table component, what we will do is, well, we already have the hook, so we will get the legs color here. And we will do that every time the legs color change. So here, we will set the color. So it's called materials. It's metal because it's the one that is used on the legs. But color equals to new 3 color from legs color. But you won't have the auto import of Three.js. What you need to do is import everything as 3 from 3. Okay, if I haven't made a mistake, it should work. Let's say legs color is not defined. So it's using legs color here from the configurator. Here we have the legs color. but here it's not available. Okay, I made it in plural. Okay, so now I'm able to change the color because on our material, which come predefined with the Blender file at the beginning, so it's here, metal, it comes white, I think it was set up. Now we are working on it. We are applying a color using Three.js, and it's the one that we define in our user interface here. So it was built here, but you can, of course, fetch it from a backend if you want to create a real configurator. So now a last parameter is the table width. So I can remove it because we will have everything and use this instead. It doesn't exist yet, so let's create it. So table width and set table width. I put 100 because it's like a percentage, and I defined on the Blender file that my table is 1 meter long at the beginning. And we need to make them available everywhere. So set table width. Now inside our table, we will want to use the table width. We will need to convert it into a scale instead of the 100 value. So it will be table width scale equals table width divided by 100. So this way, when it will be 50, it will be 0.5, and when it will be 200 centimeters, it will be 2. So we will go on the mesh of the plate, which is the first one here. We can see it by the name here and the material. We'll do scale equal, and we can define it directly here. So we'll use table width scale for the x-axis, and for the y and z axis, we don't want to change it. So we just put it here. Okay, so now if we change it, we can see that our plate is moving, but the legs aren't moving yet. So let's adjust it. So here, instead of being minus 1.5 and 1.5, we will multiply it by the table width scale. Here, here, and we do it everywhere. Of course, you could do some refactoring to avoid the ugly thing I made earlier. Okay, and now when we adjust, you can see that the table is animating it correctly and the legs are correctly animated. Now what we can do is animating it more smoothly. So if we go from 0 to 2 meters, it's quite abrupt. So we can add a light transition. To do so, we have a method called useFrame. So useFrame. And this method is called on every frame, as the name indicates, and it will help us to animate it a better way than just modifying directly the mesh. So here we won't do it. We will say ref equal plate, and we will save the plate inside a reference. So it will be plate.current.scale.lerp because it's a function to make some vectors to smoothly go toward the direction. And it takes another vector, so target scale, and a duration. So let's put delta, which is coming from here. with the time elapsed. So it will help us to animate it based on the current frame rate of the computer. So target scale equal to new vector 3. And we want it to go to what we saw earlier. So it's table with scale 1 and 1. So it's exactly the same done here, but we don't want to do it this way. Okay, and it should be fine for at least the plate. But it's very slow, so we can adjust the speed. So let's define an anim speed. I know it's 12, but you can fine-tune it the way you want. And now when we animate, we can see there's an animation. So we just need to do the same for the legs. So let's create a reference for the left and right legs.
Wasim, also, whenever you want, we can start the first round of questions because there are a few questions already. So whenever you're ready, we can start that.
Okay, so it will take me 5 minutes. So if we can wait 5 minutes, I'm good.
Of course.
Okay, perfect. So here on the legs, I can use the same reference because we never display the same legs at the same time. So it will switch from one to another. So here we have the reference for both legs. And we will have the same principle here. So target left legs and right legs. Let's look at the position we had before. So we will remove the multiplication here, and we will apply it inside our function. So here it will be the scale multiplied by minus 1.5, which was the value we had inside our model. And on the right, it's 1.5. And it's left legs. How did I name it? Yes, left legs. But current, but position, because it's the position and not the scale. And we will learn to target left legs. We will use the same speed, so it's not acting incorrectly. And same for the right legs. I forgot to remove the one that we did manually before, so let's do it. And now it should animate correctly. If okay, position undefined. So left legs, right legs, left leg, right. Okay. Okay, right legs. Should work better now. Okay, but I touched in the position here, which is wrong. It should stay 0, 0 here because the legs are at 0 on the Y and Z axis. So now by default, they are positioned correctly. And if we animate, it's animating correctly. We can see a slight difference of speed, but I don't know why actually. But okay, it's okay. Okay, Julia, I'm okay for other questions.
We can start then. The first question is right here, and it says, why would you use React through Fiber when you can do it more easily with A-frame? Please tell us the difference and when to use each one of them.
I don't know A-frame, so it's difficult to say why you will do it.
Okay, then next question is, what are the advantages in this project of using React Fiber over Three.js? With React, will we get access to a repository to check this tutorial's code and actually practice?
Yes, so the first question of using React Three Fiber over Three.js with React is the fact that you just manipulate component the way you do with React, and the same benefits than using React over vanilla JavaScript. So you have more control, it's easier, and the fact that we are using a React Three Fiber, it's making it very easy because there are ready-to-use components that we saw, like the orbit controls and the stage, which comes with the shadows, and it's not standard shadows. We have accumulative shadows, and it looks quite nice with very few effort.
And the last question, but I guess it's going to be the same answer as the first one, is can we migrate easily from A-frame to Fiber and vice versa?
Yeah, as I don't know what A-frame is, I can't answer, sorry.
Okay, no problem. Then I guess that's all for the first part of question. You can keep on going with the web experience.
Cool. So I prepared some resources, so it will answer the second part of the question about if we have access to the project. So the QR code is to have access to this page from the Google slide. So if you need it, you can go and have access to all the links. So my best advice to you is to go to Three.js journey. It's not free. It costs 100 euro to have access to the formation, but it's just gold. It's really inexpensive compared to what you will learn from it. And it comes with the basics of Three.js. And there were a few updates, and recently there were updates to learn React Three Fiber, and even creating a game using React Three Fiber and a portfolio. So you will learn the basics and advanced topic the proper way. Then there is the link of React 3 Dry, which is the library that offers some components. So it's good to go to the documentation, look at what you have at disposal instead of trying to recreate it when you can use it in one line of code and use some parameters to it. There is React Three Fiber, and it's what I showed at the beginning of the tutorial. It's really cool to look at the examples, to copy it, to fine-tune it, and to try to understand by practicing instead of just reading the documentation. And then I put the link of the final project. So both projects are linked on the GitHub, so you can switch from one and another. So either you start from scratch like me and you build around, or you use the final project and you fine-tune and add more things to the experience. And then I added the link of my YouTube channel where I put some videos on Three.js like the one we did now. And this is good for me. So thank you very much. And if there are other questions, I will answer them.
Okay, then I guess we can do the last part of questions. The next one that came right after the end was, is it possible to create a whole gaming experience? I assume not such a big AA game, or is Three Fiber not enough performant to do so?
I think yes, and there are some projects like very interesting one already available. It was an archery game, multiplayer one online. It's not perfect graphics, so if you're okay with low poly, it will work and it will be real time. I think over time we will see better things, but yes, you can create game, even multiplayer game, and it will look very smooth.
Okay, then last question is, which content do you think is the best to learn Three Fiber?
So as I said, there is the part in Three.js journey, because it was updated with 1 or 2 chapters about it. And look at the examples, because the documentation evolves constantly with new examples. And as the source code is available, you can learn from looking and reading at it.
Okay, well, if there are no more questions, I guess we're done for the day. Thank you again, Wasim, for doing the conference and explaining to us everything you know about 3D experience. If anyone here has any questions regarding Malt or globally what we do and how to optimize your profile, I will just give you my email, and you can just shoot me an email if you have any question. And if there's no more question, then I guess, oh, there's one last question. What William says, is there a loss of performance when using React 3 Fiber in comparison with Vanilla.js, Three.js, or even WebGL?
There are not. It will depend on the way you create your project. So if you create it perfectly with Three.js and not perfectly in React yet, there will be a loss of performance. But maybe it will come with better performance, because it will guide you the best way to write the code, and won't re-render every component at the wrong time. So I think unless you are an expert, it will come with better performances.
Okay, then that was the last question. Thank you everyone for your questions. It's always nice to have a really nice interaction at the end. I guess this is it, and I wish you all a very nice day, a very nice lunch also, and goodbye.
Thank you very much.